So 7 segment display, very important. How does the 7 segments display? If I have a 7 segments like this, A and B and C and D and E and F and G, how these 7 segments from an LED display? First of all, if the current passes through an LED, if the V2 greater than V1, then there is a pass of the current, the LED will glow up. So very simple as, if I have an input of is greater than V1, then the LED will be light. So the same things applies to the 7 segments. We have common anodes and common cathodes. The common anodes, they share with all the inputs, which is 3.3 for all the LEDs. If I want to switch one of these, then I have to put 0. So that means V2 is greater than V1, so we have a flow of current. So this LED will be on. The same things apply to all. The same things apply to the rest. If I want to switch any of this LED, so I have to put 0. So 0 will make the LED on, and 1 will be making off. Why 1? Why? If I put 1, 3.3, there is no difference of voltages, so it will not switch on. So now, if I want to switch in one of these LED, simple as this. Let's assume I want to do 2. So 2, that means I need A and B and G and E and D. So simple as that. A and B and G and E and D. So I have A is on, which is 0, 0, and F is off and C is off. So F is off and C is off. The rest are on. So the same things then, if I can do that, if I can do this way to switch on any number I want, then I will just use a decoder. Decoder, as you know that the decoder goes 2 to the power 3, so I can go 0, 0. So whatever inputs I have here, it will switch on the specific digits. Let's assume 0. So I have F, I have A, B, C, D, E, F and G, same thing. So if I have 0, 0, so if I have a 0, 0 here, then I am switching, I'm making a digits of 0, which is all of them is on except G. G will be off, so I will have like that. So 0. So the same things now, if I want to switch on 5, then this is 5. So 5 means that I have like this. So 5, I have A and F. So you can see A is on, C is on, and G is on, and F is on, and D is on, and the rest are off. So same things apply to all the digits. So 5, when we say 5 here, it means 1, 0, 1. So 5. So the decoder can be applied. Then I can use a logic equations to do my Karnoff's maths and calculate it. Let's assume now I want to do for E. So if I go to for E now, if I want to switch in E, I have 1 here, okay, and I have 1 here, 1 here, 1 here, 1 here, 1 here, which means it's the mean term. So the mean term, I will put it in the Karnoff's map, then I will calculate it, I will get this value. So now I have the value of E. So if I have the value of E, then I can just plug for every single one. So for E, for F, for G, for A, for B, for C. So now I can use the I can use for what they call, I can use this summary of the Karnoff's maps, and I can evaluate my values. So I have now, for example, if I want to switch on A, so then I have to use all these equations to calculate it. So for B, then I have for B is X or 3 x1, o1, x1, x0, and blah blah, all of this. But we don't do this. We don't do these what they call logic equations. Rather than when we use behaviors, what they call behavioral work. So the behavior is much simpler and much easier. And how does it work? It's simple as this. So it's very simple as this. So when it's 0, 0, 0, then I'm switching a digit of 0. So all of them will be on, except one, except G, as we said, except G. G will be off, so I will be having a digit of 0. The same things if I have 1, the same things I will switch on just only to show 1, then I will switch on this just only 0, B and C, and the rest will be off. So the same thing is applied for all of them. So if I want to switch on F, which is 15, then I have to use let's go for E. Then for E I have 1, 1 and 0. So this is A is off, A is on, B is off, C is off, then E and D and F and G, all of them are on. So that's the way we switch on. And then here, instead of using, because we know standard logics, there is X and there is don't care, and there is force, and there is weak low and weak high. So we'll just use others to include all the possibilities values, which will be, in this case, 15. So everything will be 15. So now here we have another issue here. Very important when we apply our behavioral statements. When we switch on, we're switching on all the digits. All the digits are on. So when I switch on, let's assume number 1, when I make my decoder works as 1, then 1 will be displayed for all the digits. So how shall I choose specific digits? There is in Nexus A7, there is, if I make 0, then that means I'm switching on digit, the digits that I'm choosing. Let's assume that I want to switch on, I want to enable digit 3. So the digit 3, I will just put it to 0. So digit 3, if I put it to 0, then it will just switch on the digit 3. The rest will be off. If I want to switch digit 2, then I will go for 2. Then the rest will be off. Just I put 0, then I will switch on the digit 2. So if I want to switch on the digit 3, I'll put 0 for digit 3. So now we can apply the same things as we did. So but now when we did here 0, 0, 0, we switch it on all the digits. So the values that we will show, let's assume I want to show 2, number 2. So 2 will be displayed in all the digits. So it depends upon how do I set up the enable for the 7 segments. Then now here is the trick things, the easiest way. So I have here a multiplexer which takes a value of 1 and 2 and 3 and 4. So that means I'm using a multiplexer. Only one digits can be displayed. Okay. When we have here a digits here, we're using a decoder. Decoder, as we know before, it goes from 0 to 15. If I want to display 0 to 15, so I have 0, 0, 0. I want to show 0 at the output. 0, 0, 0, 1. I want to show 1 at the output. But in this case, only one digit will be displayed. Why? Because we have a multiplexer. I cannot show the values of 4, 3, 2, 1 at the same time. Only one digit will be displayed at the output of a multiplexer, out of the system. Okay. So if I want to display 1, then only will be selected x3 down to 0. If I want to select 2, then only x7 to 4 will be displayed. If I want to display 3, then only 11 to 18 will be displayed. If I want to display 4, then only 15 to 12 will be displayed. So If I have here 15